Okay, welcome to our videos, and we are continuing with the second chapter, Probability and Statistic 1 for Cambridge International A Level. And we are going to look at the measures of location and spread, particularly Chapter 2, Cambridge edition. Just to mention, as you know, this work is combined from a powerful and lovely presentations and arrangement by Dr. James Nicholson, an authorized writer for Cambridge A-level mathematics and statistics. So as we talk about measures of location and spread, what comes to your mind when you hear measures of location and spread? We are going to focus on several things. We will look at measures of central tendencies in terms of the mean, the mode, the variance, the standard deviations of the data, and we will look at how far the subjects, how far the data can be spread out. So basically, when we talk about measures of location, what do you have in mind when we say measures of location? I want to believe that someone is in class. You should be able to tell me what is measures of location. Can somebody attempt the question? We have measures of location. What comes to your mind? That is a good attempt. Any other person? So we are talking about measures of location in terms of the position of the data. So basically what we are going to look at is the statistical values that describe the central position, or maybe typically the value of a set of data or data set. And this is what measures of location refer to. Somebody to help us with measures of spread. What is measures of spread? So we can write down that it is simply talking about position of the data set. So we can put position of a set of the data or position of data set. Correct. So how about measures of spread? Just like we have already talked about measures of location in terms of position of the data, measures of spread is also called measures of dispersion. We are talking about it in terms of how spread out or how scattered the data values are in a data set. So it is called the measures of dispersion. We will look at how spread out the data from the word spread. So it is spreading out of the data, or maybe how far the data is scattered. So any of these explanations can be accepted. So we can look at it in terms of how scattered the data is or how spread out the data is. So ideally, we are going to look at this spread out using the position of the data in terms of the interquartile ranges. So we will look at the lower quartile, the upper quartile, the median, the mean, the mode, and we are able to determine what is the modal class and what is the mean of the data given, what is the lower quartile, what is the upper quartile, and what is the median of the data. I'll come back here. You can see Frank Alkebbe in 1918 to around 2001. He was a British statistician who illustrated brilliantly why we should be careful not to rely too heavily on summary statistics. Again, summary statistics is giving you more information about the secondary data, because a secondary data is not the original data. It is a data from the primary data. And if you are given a secondary data, there is possibilities that the one who is giving that information might not give a full information. So you might have a half of information, and that will not give us a right conclusion. So the 4 data set shows here. You can see the first data set as it is illustrated in the graph. So we have 1, 2, 3, and 4. So the 4 data set shows here, this despite being very different, have identical summary statistics. So we can see they have identity summary statistics, and we can see that the mean and the variance of X and Y are the same. Their mean and their variance are the same. They have the same line of best fit. The same line of best fit, you can see the line is straight line. Of course, it has to touch any of the points. So it is just the line of best fit that is connected, and from there we are able to sketch the graph. They have the same line again and the same correlation. Extreme values can get lost in summary statistics, but often have a huge impact according to him. So we will look at some other ways, and that is why it is important now we pay attention to measures of locations and measures of spread as we use them in this particular topic. Now, what are we expecting to do in this topic? Chapter overview. We have talked about measures of location in terms of the position of the data. We have talked about measures of spread in terms of how spread out or how scattered the data is. And again, the objective is for us to be able to understand and use different measures of central tendencies like mean, the mode, the median, and variations like the interquartile ranges, that is the upper quartiles, the lower quartiles, and even the middle class. So we will look at the range, the interquartile range, and the standard deviation. For example, when comparing and contrasting set of data, we might use those interquartile ranges and standard deviation of the data. And also, for us to be able to find the standard deviation, we also need to find the variance. So the variance will help you to find the standard deviation, because later on we will introduce the formulas that is required for this. For us to be able to calculate the standard deviation, it will be the square root of the variance. So we must calculate the variance for us to find the standard deviation. Again, we are going to also calculate the mean. We have talked about standard deviation of a set of data, including a group data, either from a set of data itself or from a given total. And we are going to be using these symbols and notations. The summation of X is going to give us simply the mean of the data, or the summation of X squared, and later on we will look at this and how we can apply this to the summation of X minus A will simply give us the variance. And when we take the square root of these formulas that you can see, it will lead you to standard deviation. Now, before you start, or before we continue, there are things I want you to look at. Very quickly, calculate the mean, the median, the range, and mode of a simple set of data like the one we have. So we have a data given with this value 753, 47, 575965. Try it out. Can somebody gaze and tell me what we're supposed to do there? So can someone quickly tell me what we should do? How are we going to get we have the mean, the median, range. Let's take median. What are we supposed to do to get the median class? Okay, I take the middle number. So the first thing that we have to do will be to rearrange this data in order. we know that the median is the middle value with the data. It can only become the middle value if the data is in order. So if we rearrange this value from the lowest to the highest, the lowest value here is 3. If I take a highlighter, we have 3, we have 4, we have 5, 6, we have 5, 3 of them, 6, and then we have 7, we have 5, about 4 of them before 9. So what happened here is trying to rearrange this data. We are going to have 3, we have 4, so it is 3, 4, we have 5, about 4 of them, so it is 5, 5, 5, 5, 5, 5, 5, and then we have 6, 7, 7 is 3, so 7, 7, 7, right, and then we have 9. Here we can look at the middle number. If we count 1, 2, 3, 4, 5, and we count 1, 2, 3, 4, 5, we can see that 5 is the middle number. So the median in this case, median is simply 5, right? So we already found 5 as our middle number. Now let's look at the range. How do we find the range? The range is nothing but, if we look at the range, it is taking the difference between the highest value and the lowest value. So the range is the highest value in this data minus the lowest. So it is the highest minus the lowest, right? So if we take that, what exactly is the range therefore? The highest value is given here, this is 9, and the lowest value is 3. So we can take 9 minus 3, so the range is going to give us 6. Again, we are also supposed to find the mean and the mode. The mode is the value which appears most often. Now you can count all of them and see the value that appears most often. We can see 5 has how many? 1, 2, 3, 4. 3 is only once, 4 is 1, 6 is 1, 7 is 3. So the value that appears most often here is 5. So our mode therefore, mode is going to be 5. Now we want to find the median. The median value, we can write down here. The median value or the mean value, we already find the median. So the mean is going to be the sum of all the values. So it is sum of values that we have. So divide this sum of values by the number of values. Number of values. And we can look at the values that we have. So we can write all of them down. We have 7 plus 5, 7 plus 5 plus 3, 4, plus 7 plus 5 plus 7 plus 5 plus 9 plus 6 plus 5. So what we have is 7, 5, 3, 4, 7, 5, 7, 5, 9, 6, 5. So how many of the data values are those? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So all this divide by 11. Divide this by 11. So if we sum up this value, 7 plus 5, that gives you 13 plus 3, you get 16 plus 4, 20, 27, 32, you add 7, 41, 46, 63. So this is total of 63 over 11. Alright, so 63 over 11. If we divide this, we will simply get 5.7. 5.7 to 1 decimal place. Right, 1 decimal point. So this is how you are able to compute the mean. So we have the mean as 5.7. We have the median as 5, the middle number. We have the range. Taking the difference from the highest to the lowest, we have got 6, 9 minus 3. And then the mode, the number that appears most often is 5. And this is how you are able to compute this. Now, check your understanding. Quickly tell me, for the set of data 3520211320, what is the mean of this data? What is the median of this data? What is the range of this data? And the mode of this data. I want question 1 done in class. Test your understanding with question 2. So, what is the answer to question 1? You have just 1 minute. Okay, so are we back in class? Can someone tell me what is the mean? The first question, the mean. So the mean, we have a total value. The total value is 18. So if we take 18 divided by 2, we get 2. That's correct. How about the median? The median is, the median will also be 2, but first of all, remember we will have to rewrite it in order. If we write it in order, we will have 0, 0, 0 is twice, and we have 1, so 0, 0, 1, then we have 2, 2, and we have 3, 3, 5. Total of 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 0, 1, 2, 2. 2 is 3 of them. So it is 9 of them. And we can count from the left and right. We have 1, 2, 3, 4. 1, 2, 3, 4. So 2 is going to be our middle number. So median is equal to 2. The next value is the range, and we have said the range is simply taking the highest value minus the lowest. The highest value in this case is 5. 5 minus 0 is simply 5. Right. And what is the mode? The most frequent value is also 2. So the mode is also equal to 2. Conceptual understanding. So this is how you are able to solve this, and you have seen the mean. We have seen here the mean. In this case, we got 2. The median, we also got 2. The range is 5, and the mode is 2. So try question number 2 and check the answers in the link below this video. Average. Well, we want to look at averages. Remember, the mean is the sum of all values. The sum of all the values divided by the number of values. That's what gives us the mean. Right, and we have seen this here. When we look at the mean, we sum all the values and divide by the total number. The median is the middle value when the values are arranged in order. So you have to arrange it either from the lowest to the highest or from the highest to the lowest. And then you are able to decide and determine the median. The mode is the most commonly occurring values. So let's look at the first example. A group of students were given a short mental arithmetic test. Their scores were 7, 6, 7, 5, 6, 8, 5, 7, 8, 9. For this group, calculate the mean, the median, and the mode. So let's look at what is going to be the mean. And we have said the mean is the sum of all the values. So we sum up all these. 7 plus 6, 13. 13 plus 7, that gives you 20. Plus 5, 25, 31, 39. This will give us total of 68. 68, correct. So 68 divided by how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 10. This will give you what? 68 divided by 10. 6.8. 6.8. So 6.8 is the mean. Look at the median. In order for us to find the median, let's rearrange the values in order. So we are going to have, if we put them in order, we are going to have the lowest value is going to be 5. So 5 is twice, 5, 5. 6, 6, this is twice, and 7 is 3 times. 8 is also twice, and then 9. And now we can decide, and it is obvious, you can see from there that the median is 7. We know the median is the middle value, and the half in this data we can see halfway between the 5th and the 6th score are both 7, so we can just take 7. So the median is 7. What is the mode? The score 7 occurs more than any other, so the mode is also 7. Right. Data in a frequency table. Data in a frequency table. The frequency table on the right shows the number of children that 45 women have. You can see the table. One side represents the number of children, and the other side represents how many tallies they had, which is the frequency. To find the mode, look for the greatest frequency. The greatest frequency here is 21, followed by 12, 8, 3, 1, and then 0. So look for the greatest frequency, which is 21. Therefore, the mode is one child, because you can see very clearly here. The mode is going to be one child, because the greatest frequency is 21. The mode is just one child. To find the median, look for the middle value, and according to what we have, there are 45 values, so the median is going to be 23rd value. 23rd value with the value listed in order. So we need to make a running total of the frequency. Again, there are 12 women with no children. There are 33 women with no children or one child. So the 23rd value or median is therefore going to be one child. One child. Okay, so let's proceed. For us to be able to calculate the mean, we simply need to construct a table as the one you can see, a table of values with a further column which represents the value of x multiplied by frequency. So we have the number of children, which is x, and we have the frequency, that is how many children they have. So if we multiply this, we are going to get x of f, so or f of x or x of f. So 0 by 12 gives you 0, 21 by 1 gives you 21, 8 by 2 gives you 16, 3 times 3 gives us 9, 4 times 0 gives us 0, 5 times 1 is 5. And now we sum up this value. We add the frequency together, 21 plus 12 plus 8 plus 3 plus 0 plus 1. You will get the total of 45. And then we take the total of f of x or x of f. That will give us 51. So we have 45 and 51. 45 is the summation of f for the sum of the frequency. And y 51 is the summation of x of f for the sum of all the values. Remember, 8 women with no children each make 16 children in total. That is what that means. From here we can deduce, therefore, in case you are given to find the mean of this data, it is supposed to be the summation of f of x divided by the summation of f. So we simply take 51 divided by 45. Now let's look at the data in a group frequency table. The ages of the same group of 45 women are shown in the group frequency table. Now it is group, and we can see we have 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 49, 44, and then 45 to 49. From 15 to 19 has only 6 of them. Right. Remember, we are talking about 8 women with 2 children in this case. So here, we can either put it in a group intervals. The model class is 25 to 29 years. 25 to 29 years. You can see this is the class with the highest frequency. It is the class with the greatest. So the median is the 23rd value. 23rd value. That is the lower boundary preceding that class. The lower boundary before the class with the highest frequency. So if the class with the highest frequency is 25 to 29, what is the lower boundary of the class before that class? We have 20 to 24. So if we subtract 0.5 from 24, we should be able to get 23.5. Right. So the 23rd value, which will be the values listed in that table. So we can make a running total of the frequency. There are 6 women less than 20 years old. There are 6 plus 7 of them. That gives you 13 women less than 25 years old. There are 13 plus 15. That gives us 28 women less than 30 years old. And the median age therefore will lie on that 25 to 29 according to the group. Now to calculate the mean, you need to add up all the values. But because the frequencies are grouped, you need to use the values at the midpoint of the interval to make an estimate. So this is an estimate. So we are taking the midpoint in terms of estimation. So ideally what is happening here, we already have our interval 15 to 19. we have the frequency. For us to be able to get the mid interval, simply compute what is 15.5 plus 19.5. 19.5, divide this by 2. This should be able to give you 17.5. So this is our midpoint. But 15.5 plus 19.5 divided by 2 gives us 17.5. 20.5 plus 24.5 will give you 44.5. Divide that by 2, you should be able to get 22.5. Then we have 25.5 plus 29.5, divide by 2, that will give you 27.5. 27.5. 30.5 plus 34.5, divide by 2 gives us 32.5. 35.5 plus 39.5, divide by 2 gives you 37.5. 40.5 plus 44.5, divide by 2 gives you 42.5. 45.5 plus 49.5 divided by 2 gives you 47.5. And now we can take the product of this value with the frequency. What is 17.5 multiplied by 6? So 17.5 times 6 gives you 105 mF. 7 times 22.5 gives us 157.5. 15 multiplied by 27.5 gives you 412.5. 6 multiplied by 32.5, 175. 8 multiplied by 37.5 gives us 300. 1 multiplied by 42.5 gives you 42.5. 2 multiplied by 47.5 is 95. Now we can take the total number of the frequency. We add all these values up. We add them up. 6 plus 7 plus 15 plus 6 plus 8 plus 1 plus 2 gives you 45. Now we add 105 plus 157.5 plus 412.5 plus 195 plus 300 plus 42.5. All will give you 1307.5. 1307.5. Right. And you are able now to see that we can take the summation of MF divided by the summation of F to get the mean. So the estimated mean will be 1307.5 divided by 45. We should be able to get 29.1 to 1 decimal place. So that is about the 29 years old. It is good for you to pay attention. Age is a special case. For example, you are 19 until your 20th birthday, and you are 20 until your 21st birthday. You are 21 until your 22nd birthday. So age is treated as a special case. You cannot be the same age every year, right? Except you are a dwarf or something like that. So you will meet a way. Even dwarfs, their age increase. You cannot be one. That is it. So come back to class. You will meet a way of simplifying the arithmetic on pages 26 and 27 in your Cambridge statistics textbook. Kindly check it out. Now we have exercise 2.1. Exercise 2.1. Let's try to answer a few of these questions. Maybe question 1, then you test your understanding in question number 2. So are you able to find the answer to the first question? A golfer keeps a record of his scores in club competitions during 1 year they are 75, 77, and you can see the values the data are giving. So let's look at this. What is the mother's call? We look at the mode. The mode is most frequent value. When I look at it, I can see 77, 77, 77. So 77 seems to be the most frequent. 76 is just 1, 75 is twice, 76 is also twice. So the modal class is 77. Modal class 77. What is the median score? We need to arrange the data in order for us to find the median score, right? So if we arrange this data in order, we are going to have 74, followed by 75 twice. Then we have 76 twice. Then we have 77 3 times. And then we have 79 and 84. So we can see clearly that the middle number is because if we count the total, 10 scores are even number. We have the middle two values, which is the fifth and the sixth value. 1, 2, 3, 4, 5. The fifth and the sixth. 1, 2, 3, 4. So the fifth and the sixth is 76 and 77. So we can add that up. So we can have 76 plus 77. Divide this by 2. That will give us 76.5. So the median score is 76.5. And you can confirm the answer in your student book. There is a section of answers at the back of your textbook, and you can see the final answer but not the steps. So you can see the steps here. You should be able to get 76.5. The mean score, we know the mean is simply the total value divided by the number. So we add up 74 plus 75 plus 77 plus 77 plus 74. When you add that up, you should be able to get 770. 770, and the total is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide this by 10. So if you divide that, you get 77. So the mean score is 77. Let's look at question 2. Number of kittens in litters, frequency table. A vet keeps a record of a number of kittens in litters produced by cats in his practice. Calculate the mother size of the litter, the median size of the litter, the mean size of the litter. So we have the frequency table shown in the right hand side, and we can see the mother class. So we look for the highest frequency. It is 11, right? 11 is the highest frequency. So the mother class is going to be A is equal to 4. The mother class is 4 because 11 has the highest frequency. The median size of a litter, we need to find the total number of liters. The total number of liters, we have 1, 2, 4. So when we add all this up, this should give us a total of 39. Right. So 39, since it is the medial position, we can say 39 plus 1 divided by 2. That is 40 divided by 2. This gives you 28th value. 28th value. Now we can use the cumulative frequency, so we can add up and create another table here, and then we call it cumulative frequency. We add up this value. So if this is 2, CF represents cumulative frequency. 2 plus 4 gives you 6, and then we add up that, we will get 13. After 6 is 13. Then we have 24. So it lies on this. We are looking for the 20th value, and 20 lies within this range of 24. 20th lies within this range of 24. So the median number is also equal to 4. Now we need to look for the mean size. For us to find the mean size, we know the mean size is given by summation of f of x divided by summation of f. Right. So what we are going to look at now will be, what is our f of x? We simply have, come here, we have already 1, 2. Now we can have another table here representing fx. And then we simply multiply that. So we are going to have 1 multiplied by 2 will give you 2. We have 8, 2 by 4. We have 21. We have 44. We have 40. We have 6 times 4 is 24. Then we have 7 times 2 is 14. And then we are able to sum up that. So if we continue summing up that, we are going to see that the total value for the summation of f of x is 161. Divide this by the number, which is 39. So this should be able to give you 4.13 as the mean value. And this is what you are supposed to do in this station exercise 2.1, and you can find the answers in your student book. Conceptual understanding. Test your understanding in question 3 to 6, and also check at the link below the video for steps as you confirm the answer in your student textbooks. Quartiles and the interquartile ranges. So let's look at quartiles and the interquartile range. This is a very useful way of organizing data. We organize data or divide them into quarters, which are known as quartiles. So these data are divided into quarters, and they are known as quartiles. This dot represents 19 values, and you can count these are 19 of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. These are 19 values. Right. Q1, when we write Q1, this represents the lower quartile. Lower quartile. Q1 represents the lower quartile. As you can see, for a data set with n values, x1, x2 up to xn, where x1 represents values, it can be 1 plus 2 plus 3 up to the last value, which is xn. We can calculate the lower quartile using the formula a quarter multiplied by the total number. That is 1 over 4 multiplied by n. If 1 over 4n is an integer r, then Q1 is the midpoint of x and as you can see, it will be the midpoint of x1, xr, and xr plus 1. So this is xr plus 1. If 1 over 4n lies between r and r plus 1, then q1 is going to be xr. We will have x into r plus 1. X into r plus 1. We will see more of this better way in calculation. So these are the formulas and we are able to do that. So for instance, we want to find the q1. Simply take 1 over 4, multiply that by the total number, which is 17. You get 4.75. So q1 is the fifth value. q2 is the median, or the middle number, just like we did earlier on. And to find the middle number, we are going to take 1 over 2 multiplied by n, the total value. If 1 over 2n is an integer r, then the middle number, the median q2, is the midpoint of r, x to the power r, right? And then xr plus 1. If 1 over 2 or half n lies between r and r plus 1, then the median is xr plus 1, like you have seen. And we can compute this. The total value is 19. The dot is 19. If we take 1 over 2 multiplied by 19, you get 9.5. So 9.5 is going to be the 10th value as our middle number. The upper quartile is now the q3. The q3 represents the upper quartile. We can see, to find the upper quartile, we are going to use 3 divided by 4. Now, by now you should know, for us to find the lower quartile, we use 1 over 4. To find the median, the q2, we use 1 over 2. To find the upper quartile, we use 3 over 4 multiplied by n, where n represents the total number set. So if 3 over 4n is an integer r, then our upper quartile, which is q3, is the midpoint of xr and xr plus 1. And we can compute that in this next slide. We can see 3 over 4 multiplied by 19 gives us 14.25. So the 15th value becomes our upper quartile. And we have also seen previously how we can find the range. It is the maximum minus the minimum. We say the highest value minus the lowest value. So our maximum is q3 and our minimum is q0. So when we subtract this, we are able to find the range. So the range indicates the spread of the values. The spread of the values, or how scattered the data are. The interquartile range can as well be abbreviated as IQR. So when we write IQR, it means the interquartile ranges. So we want to take the upper quartile minus the lower quartile. That is Q3 minus Q2. So the IQR, which is the interquartile range, indicates the spread out of the middle number. That is 50% of the total number, which is going to be 100. And we can look at the semi-interquartile ranges in a simple halfway, that is using the IQR, the interquartile ranges. And from this concept, we are also going to talk about the percentiles. When you are given a number that is up to 100 and you are able to find the percentile, you can either do that by using the interquartile ranges or by estimation. Later on, we will introduce another formula that will help us to find that interquartile ranges. But note, the IQR is measure of spread, always associated with the median, which is a measure of the center in the given data. So let's consider these examples on the interquartile ranges. The score of a group of students in a short mental arithmetic test, for example, 1, were in order 5, 5, 6, 6, 7, 7, 7. So it has been arranged in order. Calculate the quartiles. For us to calculate the quartiles, it means we need the lower quartiles, the upper quartiles, and even the middle number. So let's see, like, how many numbers are those? We have 1, 2, up to how many? There are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So there are 10 numbers. So if we have 10 of them, n is equal to 10. And we know the formula for lower quartile is supposed to be 1 over 4n, right? So this is supposed to give us 2.5. 1 over 4 times 10. 2.5. So Q1, this is equal to Q1. And we can see the third value in the ordered list because it is ordered. The third value is 6. The third value is 6. So we can say that Q1 in the ordered list is equal to 6. Right. Again, we want to find the middle number. Q2 is a half multiplied by n. So a half times 10 will give us 5. So Q2 is the midpoint of the 5th and the 6th value, since it is arranged. So these are both 7. So the median is 7. We can see Q2 is going to be 7, looking at this arrangement in the data. And we can look at Q3, the upper quartile, using the formula 3 over 4 times 10, which is n. This will give you 7.5. And Q3, 7.5 is going to be 8, the 80th value. So Q3 is 8. Then we want to find B, the interquartile range. The interquartile range, IQR, is nothing but the highest maximum minus minimum, 8 minus 6, which will give us 2. Because we know it is 6 from calculating the lower quartile. So 2 is the answer to that question. Test your understanding, confirm your answers in the link below the video, and also check your student notebook. Though your student notebook has no steps, so confirm your answers with steps in the link below this video. Variance and standard deviation. Variance and standard deviation. The mean of a set of data is given by the formula. As we have talked about the mean, the summation of the total number or the total data divided by how many data sets we have. So the mean is given by this formula, summation of x by n divided by n, where data is when data is in a list, or we can use the second formula when the data is in the frequency distribution table. The summation of f of x, or the summation of xf, divided by the summation of f, where f represents the frequency, x in each data value, n is the number of data values, and f is the frequency given, and we will see that. Remember the Greek letter sigma, which we refer to as the sum or summation of that. Sigma. Sigma stands for the sum of when we have added all the values together. So for us to be able to find a mean, we need this notation, this side. So far, you have met two measures of spread. That is the range and the interquartile range. Each of these measures uses only two values. Another measure of spread, one which uses all the data values, is the variance. Now pay attention to this. So far, we have seen only two, but we have not seen variance. We have seen the range and the interquartile ranges, and each of them measures uses only two values. Another measurement which uses all the data values is what we refer to as the variance. So the variance of a set of data is defined as the average of the squared distance from the mean. The average of the squared distance from the mean is what we refer as the variance. And the variance is given by this formula. We want to take the average of the set of data. So we take the x, that is the set of data given, and the mean. We subtract the mean, square this, divide by the total number, since we are talking about the average. Or we can use the second formula for a data given in a frequency distribution table. The second version of the formula is generally the easiest to work with. The variance is normally denoted by that notation. So we should be able to look at this. To show that the first equation is equal to the second equation, one can derive from the other. Deriving this equation might not be part of this year 12 specification. But since Pure 1 and Pure 2 is accepted for year 13 edition, and S1 and S2, it is important that you pay attention to this derivation. So you look at how it is. We derive using the first formula. We want to show that this is equal to that. So the sigma, which is the summation of x minus the mean divided by n squared, is equal to the summation of x squared minus 2xx. That means try to open up this bracket. We have x minus the mean squared. And you did, even in your Pure 1, how to do expansion. Before binomial expansion, you have done simple algebraic expansion, and you did complex expansion by using the Pascal triangle. So when we expand this, we simply get x squared minus 2x and the mean plus x, the mean squared. That is the mean squared, all this divided by 2. And then we do a little algebraic and simplification, we should be able to get this answer. So how do we then find the standard deviation? The standard deviation is the square root of the variance. So we simply square whatever we get as the variance. So if you calculate and your answer is 2 as the variance. So if the variance is 2, standard deviation is simply what is the square root of 2. Right? So that's how you'll be able to be manipulating this. The standard deviation is the square root of the variance. It is a measure of how spread out the set of data is, or how scattered the data is. And it is in the same unit as the data. And we will see that with this example. So look at example number 3. In this example, find the mean and the standard deviation of the set of data 11, 13, 14, 16, 18 already arranged. Right. So very quickly, we can start by looking at the summation of x. The summation of x, we have 11 plus 13 plus 14 plus 16 plus 18. This should be able to give us 72, right? So the mean which is given is going to be 72 divided by how many? 1, 2, 3, 4, 5. Divided by 5. 72 by 5 is 14.4. Correct. The standard deviation, we want to find the standard deviation, so we can simply find what is the summation of x squared. So we simply take 11 squared plus 13 squared plus 14 squared plus 16 squared plus 18 squared. If you find this, you should be able to get 1066. Correct. 1066. So if we have 1066, the variance, therefore, the variance, notation for variance is going to be 1066 divided by 1066 divided by 5. So this is need to get rid of this. Divided by 5, because the total number is 5 minus 14.4 squared. So you will find out our variance is going to be 5.84. Now, for us to find the standard deviation, because this is the variance, it will be the square root of the answer we got. So it is the square root of 5.84, that is the standard deviation. This should be able to give you 2.42. So three significant figures. Again, you can use the formula summation of x minus the mean that we have, then square this. If we use the formula, we are going to have the summation of x. It is going to be 11 minus, the first value is 11 minus 14. We got 14.4. So it is 14.4. Then we square this. Plus we can have 13 minus 14.4 squared plus 14 minus 14.4 squared plus 16 minus 14.4 squared plus 18 minus 14.4 squared. So we compute that. We should be able to find the total of 29. Plug that in your calculator, 29.2. So the variance is 29.2. We take 29.2 divided by the number, the total value, we should be able to get 5.84. And then to find what is the standard deviation, we simply take the square root of 5.84. You should be able to get the same answer as here. So you can use the formula or you can follow these steps. Example 4. The number of children x, that the number of children is given as x, that each of a class of 30 students has in their family was recorded. Find the mean, the standard deviation of the number of children in a family for this set of data. Again, we are given the summation. You work with what is given. Summation of x 66. Summation of x squared 165. Right, so this is given. So the mean therefore is going to be, let's take a brighter color. So this is going to be 66 divided by 30 because it is 30 students. So that gives us 2.2. The variance is going to be 165. Divide that by 30, which is the number, minus 2.2 squared. And this should be able to give us 0.66. And standard deviation is nothing but the square root of the variance, 0.66. This will give you 0.812 to 3 significant figures. Number 5. The number of parts. The number of parts, x, a golf partakes on each of the 18 holes in a round is recorded. Find the standard deviation of the number of parts he takes on each hole, given that the summation of x minus mean squared is 4.944. Conceptual understanding. Given. So if something is given to us, we use it, right? So the variance is nothing but 4.944 divided by how many are there? 18 holes. 18 holes by 18. This should be able to give us 2746. And for us to find the standard deviation, we simply take the standard deviation is the square root of that answer, 0.2746. This should be able to give you 0.524 to 3 significant figures. Number 6. The height of 142 plants are recorded in the table, where, for example, class 65 to 70, that is the interval of that class, means at least 65 centimeter and less than 70 centimeter tall. We are to calculate estimate of the mean and variance, and we have a table given. For us to do this, we need to calculate the midpoint of each class. That means we need more tables. Okay, let's do that. So we have classes given 55 to, so we have 55 to 60. So we have these classes. We have 55 to 60. So we will have class Then we have the midpoint. Midpoint can be given as M. Then we have let's have the frequency. Let's have frequency multiplied by midpoint, MF. We can have the midpoint squared multiplied by F. Let's start with that. We can add if need be. So this class 55 to 60 have a midpoint of 57. We can do 55.5 plus 60.5. Divide that by 2. We should be able to get 57.5. So this is 57.5. You can use a different color. 57.5. Here we have the next class is 60 to 65. And if we do 60.5 plus 65.5, there are two ways of doing that. You can do 60.5 plus 65.5. Or you can do 55.5 plus 64.5. Each of them should be able to give you 62.5. We do the same. We have the next is this is 65 to 70. Right. 70 to 75. We have 75 to 80. We have 80 to 85. And then we have 90. We have 85, sorry, to 90. Okay. So looking at the midpoint, this is 62.5. 65.5 plus 70.5 divided by 2, 67.5. 72.5. Right. 77.5. 82.5. 87.5. Compute that. 85.5 plus 90.5 divided by 2, 87.5. Good. Now we can look for the frequencies given in the table. We have 2, 11, 37, 54, 28, 91. Simply put it. So 2, 11, 37, 54, 28, 91. Again, we can take the summation of this. What is the summation of F? If we add the total number, we should be able to get 142. Correct. Now let's do the sum. This M minus F, that is the midpoint multiplied by F. 2 times 57.5, 115. We are going to get 68.7.5 to 24.97.5. 0.5. That is when you do 37 times 67.5. Here we can get 3915, 2170, 74 2.5, 87.5. And we can do the summation of this. If we add all this up, we should be able to get, that is the summation of f of m or m of f, should be able to give us 10,215. And then we also need to do the midpoint squared multiplied by f. So we have to square the midpoint and multiply the value by the frequency. The midpoint is, we got the midpoint here 57.5. 57.5 squared will give you 3306.25. Multiply that by the frequency of this class, which is 2. So you get 66. So this becomes 6612.5. Here we are going to get 442, very big numbers, 96, 8.75. Here we are going to have 168, 581.3. Then we have 283, 837.5. We are going to have 168, 175. We have 61,256.25, 76, 56.25. So these are the values, and we can take the summation of this. So the summation here, the summation of the midpoint squared multiplied by f will give us 7 million. So you add up all the values, you should be able to get 739,087.5. Now we want to find what is our mean. Our mean, therefore, is going to be the summation of f of m or mf, which we get here as 10,215. So it is 10,215. Divide that by 142. 142. This should be able to give you 71.9 to 1 to 3 significant figures. Correct. And the variance therefore is going to be, the total value we have got is 739,087.5. We write all these values, 739,087.5, right. Divide this by the total number, which is 142, minus what we got already as 10,215. Divide this by 142, then square this. All this squared. This will give you 30.0, 3 significant figures, as the answer. We are simply looking for the midpoint. We needed to find the mean and the variance, and we have done that. The mean and the variance. So sometimes you do more of simplifications. You might do more work than the other depending on the question. What does standard deviation actually mean? A good visual idea of standard deviation is to imagine a histogram of beta. Later on, when we start looking at representation of betas, histogram is one of those ways we represent betas. So for a roughly symmetrical distribution, a spread of 4 standard deviation covers approximately the central 95% of the distribution. And we will see that in recomputation. I have included some exercise for your understanding. Test your understanding, confirm with the answer that I have indicated on the link below the video. Also, the answers are at the back of your student textbook, though without the steps, for you to get the steps by steps. And most of these exercises are exam style questions, so you have to make sure you try all of them. Which average should you use? Sometimes you are faced with this question: which average should you use? The simple answer is that if one measure was always the best, then there would be no need for any other. There are different ways to measure. That's why we have measures of locations and measures of spread. So which one? So it depends, right? It depends on the equation, and it depends on what is needed, and it also depends on you as a person. Which formula is more preferably to you? So it depends. The mode is referred to as an average, but it is not the same sort of measure as the median and the mean. If you could only have one of these three, the mode is not the one you could choose. The median is the middle value, or what we call Mr. Average. The middle value, Mr. Average, right? Half of the other values are bigger and half are smaller, while the mean is the value which gives everyone an equal share. And you would like that, right? You want to get an equal share in 3 mangoes. If I give you guys 3 mangoes in class, you would like to get your share, isn't it? So this suggests a strategy for deciding which measures to use. If the total of the values tells you something of interest, then the mean is likely to be more appropriate. Note that it needs to be the total that tells you something of interest. The total value, the total data set will help you to know the measure to use in deciding what is needed. So the most appropriate average is not simply a matter of whether the data are symmetrical, whether the data are outliers. Using a set of data for different purposes may mean that different averages are appropriate. So when we use different measures, we are simply looking for what is appropriate, so that it helps us to calculate and get the right answer. There is, however, one golden rule: the measure of center. There is one golden rule, and you must pay attention to this. The golden rule is, look at the golden rule. The measure of the center and spread are not interchangeable. The median goes with the interquartile range, and the mean goes with the standard deviation or the variance. And this rule must be obeyed in all computations. Coding. The next topic is a subtopic under this. Coding, preferably the last, as we try to do finer touches in this topic. In your ICT, you've learned about coding. It is a way of programming a particular thing. When you code an object, it can happen that way, right? Coding. What do you understand, or what do you know about codes? What do you know about coding? Coding is a way of simplifying statistical calculations. This is a way of simplifying statistical calculations. Are we together, guys? Each data value is coded to make a new set of data values which are easier to work with. Right. So we code in order to get an easier way of finding answers. So coding is a way of simplifying statistical calculations. Each data values is coded to make a new set of data values which are easiest to work with. So you will have to code values using formulas like, later on we will talk more about those formulas, but usually you have formula like y is equals to x minus a divided by b. This type of formula will be needed, where a and b are constant given with equation. Constant given with the equation. That is, we can say if data are coded using the formula x minus a divided by b, the mean of the coded data is given by y prime is equal to x minus, now we talk about mean, x bar minus a divided by b in terms of the coded system. The standard deviation can as well now be computed using the formula to be equals to the mean multiplied by the variance, divide that by b. We will see that. So let's look at this diagram. The diagram shows two sets of data. We have two sets of data set 1 and data set 2. So data set 1 represents the ages in years of a group of people, and data set 2 represents the ages of the same people 15 years later. So we will see that all the data values have shifted by 15, right? And this will be illustrated in the second point. It has shifted by 15. So the mean of dataset 2 will be the mean of dataset 1 plus 15. It is just coded. We simply add the 15 that we have. So this is what we'll be doing in terms of coding. And all these are simple explanations that will help you understand what we mean by coded system. So if a set of data values x is related to a set of values y, so that y is equals to ax plus b, then mean of that y is ax, mean of x plus b, and standard deviation is simply going to be y equal ax standard deviation of x. Interesting, right? You can use this idea to transform or code a set of numbers. Any number given, you might do this to make the numbers easier. Another use of coding is in standardizing different data sets for comparisons. So let's look at examples. So here is the group data for example 6. On the highest, you remember we calculated on example 6, we got the height to be 142 planks. Recall that the class 65 to 70, for example, means at least 65 and less than 70 at all. So we are told to use the coding m equal to m minus 57.5 by 5 to find the mean and the variance of this data. So we have been given the coded, so we want to use it. So for us to use that, we might need to formulate another table, because this table that we have gives us the class width, it gives us the midpoint, it also gives us the frequency. So we can simply add If I add maybe midpoint multiplied by the frequency, I can add also midpoint squared multiplied by the frequency. So we can add that in that table. Don't mind the drawing. This is freehand. So if we do this, we can simply multiply what is 0. We will have the midpoint of this class, 57.5. We can get 0, right? So we can have M, capital M, capital M. So when we use and apply our code, remember here the code is simply M, capital M is M minus 57.5 divided by 5. So you have M is equals to M minus 57.5 divided by 5. So if we do the first one here, M is 57.5. So that becomes 57.5. Just a minute, we have 57.5 minus 57.5 divided by 5. This is 0. This is 0. So our first M here is 0. We do the same. Our M here is 62.5 minus 57.5 divided by 5. Here we are going to get 1. Then we have 67.5 minus 57.5 divided by 5. We are going to get 2. If we do the same by coding, we will get 3, we will get 4, 5, and 6 by applying this code. You simply take the M value, subtract by 57.5 divided by 5, you get this M. 0, 1, 2, 3, 4, 5, 6. This is the coded system. Now we can multiply this coded system with F. So what is 0 multiplied by 2? 0. So we have 0, we have 11. We will have, because it will be 11 multiplied by 1. 37 multiplied by 2, 74. We have 74, we have 162. We have 112. We have 45. And finally we have 6 multiplied by 1 is 6. Then we square 0 squared multiplied by F will simply be 0. 11 squared multiply this by F. So this will be 11. 11. Then we have 148. We have 486. 486, 448, 225, and finally for 6 we can have 36. So we have expanded this table to have the columns for M, MF, and M squared F. So now we can add up all the values of F. We know that it is total of 142. How about the summation of MF? The total summation of MF is going to give us 410. And the summation sigma M squared F, M squared F is going to be 1354. 1354. So now we can go ahead to find the mean. We can put it as M bar is 410 that we got here. divide that by the total number, which is 142. This should be able to give us 2.887. The variance is going to be therefore 1354 that we got here. 1354 divided by 142 minus m squared sigma, that is m bar squared. So this will be, compute this, you should be able to get 1.19857. So to find the mean and variation of variance of the coded data, we can do the m. So what happens is the small m is equal to the capital M bar, multiply that by 5 plus 57 because we have m minus 57.5. So small m will be m bar times 57.5, which is going to give us 2.887 times 887 times 5, right? Times 5 plus 57.5, and you should be able to get your final answer here as 71.9. So standard deviation therefore is going to be 5 squared times what we got. This will be equal to 1.19875. So 3 significant figures. And this is how you apply a coded value, using a coded value in order for you to solve that. Important notice, without coding, you can use this value as it is given, so substituting it in the formula, and you are able to find your final answer. Test your understanding and check the answers in the link below the video. You can as well confirm your textbook for the answers. For steps, you can check the answers. I have included these exam style questions for your practice and revisions. Ideally, in this chapter, we have looked at Q2 as the median. To find the median, we need the formula 1/2 multiplied by n as a number. We have also looked at the upper quartiles, the lower quartiles, and the median class. And all these formulas we have talked about it extensively. For a set of data, we can use these formulas for the median and for variance. So this will be the end of this video and the end of chapter 2 statistics. The end of chapter 2 statistics. So in chapter 3, we will be continuing with representation and analyzing data. Data can be represented using different ways. We can construct stem and leaf diagram, box plot, histogram. We can use different ways, and we will also look at the use of cumulative frequency graph to estimate things like the median, the quartiles, and the interquartile range. See you in the next video.